Stage 1 and Stage 2 are pressed for flight.
High flow engine purge is enabled. Water deluge is activated.
Ten, 9, 8, 7,
No,
6,
leave it on.
5, 4, 3, 2.
Stage 1 propulsion is nominal.
They really do go up so fast, with a beautiful liftoff of Electron from the pad at Launch Complex 1. We're now T plus 40 seconds into the mission and approaching max Q, or maximum aerodynamic pressure, at the 1 minute 9 mark. Max Q is the moment during launch when Electron experiences the highest amount of mechanical stress from the dynamic pressure, which is a function of its velocity and altitude. We'll be coming up on max Q in just a few seconds.
We could pass maximum dynamic pressure.
And there's the call that we've successfully cleared max Q. All is looking good with our trajectory, and Electron is performing nominally.
Stage 1 guidance is nominal.
AOS Chatham Station.
We're quickly approaching the next set of milestones in this mission. First up will be main engine cutoff of the 9 Rutherford engines on Electron's first stage. This is when the engines throttle down before the vehicle separates into sections, or what we call stages. Following that, the sole vacuum optimized Rutherford engine on that second stage will fire up to continue the journey to low Earth orbit. We're a few seconds away from those events, and those calls will come in quick succession, so we're going to cross back to mission control now.
Stage separation successful.
Stage 2 ignition confirmed.
And you've seen it on your screen there. We have had a successful MECO, first and second stage separation and ignition of the Rutherford engine on Electron's second stage. Coming up in a few seconds, Electron's fairing will separate. The fairing is the casing at the top of the rocket that protects the satellites as they travel through Earth's atmosphere.
Fairing jettison succeeded.
And,
High voltage battery discharge.
and there they go. The fairing has cleanly separated and
Stage 2
fallen away
propulsion
from
is nominal.
Electron, which is continuing on a nominal trajectory.
Stage 2 guidance is nominal.
Electron's trajectory continues, as you'll often hear us say, nominally, with a current speed of just under 10,000 kilometers per hour and an altitude of about 165 kilometers, and we are now at about 4 minutes into the mission.
Some absolutely stunning views of Earth from Electron's Stage 2 camera. The journey toward low Earth orbit is going smoothly so far, and we're about a minute away from battery hot swap.
Starting throttle down on stage 2.
Stage 2 propulsion remains nominal.
High voltage battery discharge nominal. Approaching hot swap.
As we mentioned before, in the next few moments we'll be coming up to the battery hot swap, a maneuver that's very specific to the Electron rocket as the only launch vehicle flying with battery-powered electric pumps feeding our engines. When the first set of batteries are depleted during launch, we switch to a fresh one to power the engine for the rest of the mission. Sometimes you can see those battery packs fall away after the event, so let's keep an eye on the live feed from Electron and listen into mission control for the call.
Battery jettison confirmed.
Propulsion remains nominal.
Hot swap.
And there we go, that's confirmation that the battery hot swap was performed successfully on Electron, and propulsion continues to look good for the rocket's second stage Rutherford engine. We're just a few minutes away from orbital insertion and kick stage separation on this mission. Electron is currently travelling at over 15,000 kilometres an hour and at an altitude of 276 kilometres above us.
Current altitude is 280 kilometers, speed 4.9 kilometers per second.
If you're just joining us, we have had a successful liftoff of our They Go Up So Fast mission. About 2.5 minutes into flight, we had main engine cutoff, stage separation, and stage 2 ignition. We're coming up on separation of the kick stage at around T plus 9 minutes. The view on your screen is Electron's second stage Rutherford engine. This engine is the same as the 9 engines that lift Electron off the pad, but with an extended engine nozzle for optimized performance in the vacuum of space. We are looking good for SECO or second engine cutoff shortly.
And we entered stage 2 burnout detect mode.
Shortly, Electron will shut down the Stage 2 Rutherford engine to allow for a clean separation of the kick stage. That will place the kick stage in an elliptical orbit around the Earth for a coasting period of around 40 minutes or so. That event is coming up shortly, so we're going to switch back to mission control to await the confirmation.
Stage 2 guidance is in terminal, 10 seconds remaining.
SECO confirmed.
And stage 2 separation confirmed. And now transfer over to kick stage.
Fantastic news that the Rutherford engine on the second stage has successfully shut down as planned, and the kick stage has cleanly separated.
The kick stage is now going into its coasting phase for about 40 minutes or so while we wait for the circularization burn from our innovative Curie engine.
Hello and welcome back to Rocket Lab's mission They Go Up So Fast. Very soon, this third stage of the rocket will perform a short burn of its Curie engine to circularize its path around Earth, ready to release this mission's satellites to their ideal positions. We are at T plus 47 minutes into the mission, and we're just waiting now for that engine burn, which is expected to occur shortly.
While we're waiting for the Curie burn to finish, I'm going to tell you a bit more about what will happen next for our customer satellites. With 4 of the satellites on this mission set to join their respective small-sat constellations, pinpoint payload deployment is absolutely critical. The ability of the kick stage and Photon's Curie engine to perform multiple relights means we can be very specific about where all of these satellites are deployed, even though they're all flying on the same vehicle. First, Photon, operating as a kick stage at the start of the mission, will deliver the majority of the satellites to a 550-kilometer circular orbit. That deployment will occur over a period of around 5 minutes or so. Then, with a short burn of the Curie, Photon will actually lower its altitude 100 kilometers closer to Earth to deploy the final payload to a 450-kilometer orbit.
But even then, we are still not done, because after payload deployment, our operators in mission control will issue a command to transition the kick stage into spacecraft mode and begin our secondary mission objective to test out new systems on our own satellite. This Photon will build flight heritage across its subsystems for our capstone mission to the moon for NASA this year, as well as our private mission to Venus in 2023. We've got some new and exciting technology to demonstrate on Photon this time, including deep space radio capability, sun sensors and star trackers, and an upgraded reaction control system for precision pointing in space. We're coming up to the release of the first satellite from Electron shortly, so let's listen in for the calls from mission control. So we've had confirmation that the first satellite has been deployed from Electron, the M2 smallsat from the University of New South Wales, Canberra Space in Australia.
Up next is the Centauri 3 Internet of Things nanosat from Fleet Space. And there we go. We have confirmation of another successful deployment, this time for Fleet Space. 2 down, 3 to go at this orbit. The Curie Hatchling 1U CubeSat from CareWeather is up next. CareWeather is focused on saving lives through better forecasting of Earth's extreme weather.
Now what you're seeing on your screen is a simulation of payload deployment. We will confirm all payload deployments on our social media channels shortly. Great, and there is the third payload deployed from Electron. This one is tiny, it's about the size of a bagel. But next up is the small sat for SMDC. This one is the size of a loaf of bread and is being deployed by Rocket Lab's Maxwell CubeSat dispenser.
And as you can see in the simulation, the payload from the US Army's SMDC has been deployed to its 550-kilometer low Earth orbit. The final payload at this orbit is up next, and it's the Myriota 7 satellite.
We are just waiting now for the deployment of the Myriota satellite. And there it goes, that's the 5th satellite on this mission deployed. The Myriota has been deployed to its orbit as planned.
Congratulations to all of our mission partners so far, and let me be the first to welcome you to your new home in orbit above the Earth. We have one final payload to deploy on this mission, the Gen 2 spacecraft from Black Sky Global. But as we've mentioned before, we have to drop the kick stage to a lower orbit first.
We'll do this with a second relight of the Curie engine to change the kick stage's altitude, and 40 minutes or so after that event, Curie will be ignited for a third time to circularize its orbit around the planet at 450 kilometers above us. Then soon after that, kick stage will transition to photon mode and remain in that orbit to test out some of the spacecraft's new technologies.
We won't be live for confirmation of payload deployment, but it should look something like this. Keep an eye out on our social media channels for verification of final payload deployment and the transition to Photon later today.
And a huge congratulations to the entire Rocket Lab team on reaching this awesome milestone of over 100 satellites on orbit. And a huge thank you, of course, to our mission partners for choosing Electron to fly on your mission. And a final thanks to you for joining us for this launch. I'm Uriel Baker.
And I'm Scott Moeller. This is Rocket Lab Mission Control, signing off.